So yeah, and today I'm going to talk about things that excites me. Anyone using Kafka in this room today? Anyone using something to process a string? Kafka Streams, Flink, Spark. What else? What we have else? What else we have? Well, there's nothing else we have. Okay, and today I'm going to talk about specifically about Flink. I work in this industry, stream processing industry, and also trying to find the ways how I can, start talking about these complex things that I will be talking about in the simple terms. And one of the things that I came up with is that, I do have favorite coffee place where I go every day. And sometimes I meet new faces there, and this new person, new barista doesn't know what I usually order there. So, and I need to go and explain myself every time what I want. I want a cappuccino, I want a skim milk, I want an extra shot of espresso, and all these kind of things, like smaller recipes. And every time I need to do this over and over again. So this particular barista doesn't have any memory about my existence. So it doesn't have a memory about previous orders, let's put it this way. So, and this barista will be demonstrate a stateless stream processing, something that you process orders in order to, do something with this. In this case, it will be issue another job that will prepare coffee. And this particular barista or this particular job, stream processing job that is totally stateless, doesn't care what happens before, doesn't care what happens after. But when I meet my favorite barista there, he always knows what I want, always knows what's going to be my order. And in this case, he can also count how many times I ordered this particular drink. So he has a list of record. So this particular barista will be representing our stateful stream processing. So in order to execute this order and provide me report of how many cups of coffee I drank for the last week, it requires a little bit of knowledge. It requires a little bit of memory of the previous requests or previous the messages that come through this topic. So essentially, we're going to be talking about stateful stream processing, why it's difficult, how Flink solve it. I'll show you a few bits of code, and after that, we're going to have a break, and after that, you will have a Dr. Venkat. That's obviously 2025. Every image here is generated by AI. Like it or not, it's totally saved me tons of time. Instead of finding particular image, I can just generate. And yeah, let's do this. My name is Viktor Gamov. I work as a principal developer advocate at a company called Confluent. Anyone heard about Confluent? Yes. I was 4 years ago, for example, asking these questions. Not many people knew. Now everybody knows the Confluent. It was a company founded by original creators of Apache Kafka. We started the Confluent Cloud, blah, blah, blah. And now we also going in the world of the managed service for stream processing. We have a Flink. We have a managed service for analytical workloads and data lakes called TableFlow. Talk to me about this, but I'm not going to talk about Confluent Cloud or Confluent today. Back in the day, it was really 2020 something. I wrote the book together with my friends and coworkers about Kafka called Kafka in Action. If you're interested to pick up this book, it's still quite good conceptually. Even though many things changed, Kafka now doesn't have a zookeeper. Version 4.4 totally eliminated zookeeper in order to have its own the homebrewed consensus mechanism. So it's pretty cool. Now, probably it's going to be the most important slide. You can take the photo of this slide because this video would be recorded. You'll have slides, you'll have a demo, and you have tons of other talks in this particular topic. Some of the talks similar, some of the different. And I don't know where particular topic was already there, but some videos and code would be there. It's my website. If you want to tweet about this talk during this talk, you can always use my Twitter handle or Blue Sky or LinkedIn or whatever you prefer. They conveniently placed in the bottom of every slide, basically over here. All right, so again, another the AI-generated image of squirrel riding waves of stream holding a cup of coffee. It's kind of because logo Flink is squirrel, Java logo is coffee, and streams, streams, right? So I think it's logical. Now, the Flink It is Apache Flink. It is an open source project founded somewhere in Europe, specifically in Berlin somewhere. That's why, as far as I was told, Flink is somehow is a squirrel in German. Is it right? Any experts in language? No? I also don't know. But the logo is cute. It is a framework and processing engine for everything that process stateful or stateless streams. Streams can come from any source. Flink doesn't have any specific prerequisite where the data should come from. It can be files, it can be messaging systems, it can be Kafka, it can be Kinesis, it can be Pulsar, it can be whatever you have. CDC, Flink supports CDC, meaning that it can read the changes that happens on database directly into the system. And well, does some sort of processing. You can do multiple interesting things with this. So there's two types of streams that we will be dealing with. And the way how the Flink likes to see them, specifically things that we call batch in our life, meaning that it's a finite stream of something, or like a bounded stream. It's just one of the corner cases of unbounded stream. So in API that Flinks will be exposing to developers, it's unified. So you're not specifying, saying, hey, I'm going to use string or batch. Just based on the source, it will decide we will stop the job, or we continuously will be reading this source and continuously will be processing. So that's one of the things where the Flink, for example, different from things like a Kafka streams, where Kafka streams has intimate connection with Apache Kafka because of the name, right? And all the data needs to come from Kafka topics. In Flink, it's not necessarily. We can even generate data from within Flink job and send this towards the data stream. So let's talk about some of the key concepts. As I already mentioned, Flink provides the ways how the data can be brought from different sources. It can be Kafka, it can be different apps, API calls, connectors. Virtually, technically, if you have a Kafka and some sort of connector, you can bring data from virtually everywhere. But in some cases, sometimes people we don't want to use Kafka, or we're not using Kafka, or we're not using Kafka today, but we still want to do processing. We still want to do something with Flink. So that's why people would pick up this different connector for different databases. Same thing with results. Flink takes one event doing something with this, and it will send it to output. It is not necessarily needs to be this way. You can even have a sink that will be simply writing down something into a standard output. It's also possible. So, and the Flink will be in between. So it is as I said, it's a framework, but also it's a computational engine. So you will be running cluster. You will be running cluster which contains multiple different components, and the jobs that you're writing will be submitted into the cluster. So let's take a look on what happens inside this particular job. So Flink has this concept of DataStream API. As a Java developer, you will be talking to DataStream API most of the times because majority of the getting started guides will tell you to do so. There's another approach I will show you in a few seconds. Another approach will be using slightly different API that we as a Java developers not very much so kind of like used to, but it's still a thing and it's quite powerful. Now let's finish with the DataStream API. So we're starting with getting execution environment. Regardless if we will be running this in a laptop or we're submitting job to the cluster, this is kind of like the way of Flink to get information about where this job is actually running. If this method will be invoked in the local environment, in this case, local mini Flink cluster will be get information about the execution environment. If we're running this inside the cluster, I'll show you what is going to be when we will be running this on a particular task manager or like job manager. And from here, this is like a very simple use case how we can pipe in data in our data flow. So in this particular case, we take the list of words that we want to process. And in this job that some of you might notice very similarity to Java util stream, the approach of kind of like a pipelining different operation. As my t-shirt says, we are streaming to the future one event at a time, meaning that one event that will or one thing, one occurrence of one thing will happen, and this apple thingy will go through this pipeline, and after that banana will go through this pipeline, and after that cherry will go through this pipeline, and date will go through this pipeline. Meaning that it's not going to be getting this in a batch. In this particular case, it will send each individual message through this pipeline. So in this case, we simply writing down this into to the console in just a standard output, and we're getting some results back. And I will show you how this code runs after. We can talk about some examples. And this is pretty much it. Inside this block, you can do whatever you want. You can use whatever libraries you want. The only important thing is that when you're building this job will include all your dependencies. If you use external libraries, because all these things will be sent into the cluster, so this stuff would be executed inside this. Flink, as many modern data streaming systems or data processing systems, use this concept of directed acyclic graph, or DAG, meaning that don't be confused with RAG, because it's also 3 letters and or AG, but it's absolutely different things. But like in the world of AI, everyone talking about RAGs this day, not many people talking about DAGs this day. Directed acyclic graph, meaning that it has a direction. So it goes from one point to another point. Acyclic, there is no cycle, so we cannot loop inside this particular the graph. And it has a beginning and the end. So we expressing every element, every step of transformation that we're applying to our streams of data in the form of this graph. Individual node will be representing operator. So our function that will do something. Either it's going to be like a mapping function that doesn't have any state, or it will be aggregations function that will require some intermediate state recorded somewhere. So one of the operations that Flink supports, it's a stateful stream processing. It requires some of the coordination between nodes, and data can come in a format of kind of like partitioned or unpartitioned. In case of Kafka, if you want to have some sort of like a parallel read of multiple topics in the same time, we're running this in certain level of parallelization between the source node. So it's going to be, from the code perspective, it's going to be one particular node, but this will be scaled across multiple task managers. We're going to talk about task managers in a second. Next thing is that we will be able to perform a certain grouping, but certain criteria. Sometimes when we do any type of aggregation, now we need to group elements with the same key or same grouping key in the one location. So in this case, we're going to group only yellow colors or only blue colors and things like that. And this is important because you don't want to, every time when you need to perform some sort of join, you need to find the ways how the data would be collocated, the data that you want to join on certain nodes. Now, and that's why operation of changing where the data initially come from to the place where data would be more, what word I'm looking for, processed more optimally. So that's why we need to repartition this data. So data from Kafka topic can come with multiple partitions, can come from one partition. And our logic, I'll show you some code after that, say we do have movies, and movies has ID, and we have information about movie ratings. We want to have a stream that will include rated movies. So we need to collocate ratings with the same movie ID in movie with the same movie ID on the node that will perform our join. And the Flink will be able to, through the calling of certain API, will be able to move data around and shuffle data around. One of the things is important that when you performing this type of computations, when you do kind of like a joining or data enrichment and all these kind of things, you need to think about like this, because this is operation that's network calls. Like data will be literally sent between different computation nodes. And as a result, we want to send the result somewhere. Either it's going to be console, or it's going to be some connector that will be syncing to database or syncing to Kafka. So this data will be end up in one node that will be sending this to one place. So all these things happened majority of the time, you just need to use APIs, and all these things will be handled for you underlying specifically like repartitioning and like rebalancing and the parallel. Usually it's a configuration-wise, just a configuration that you need to apply into into your job. So one of the APIs that I mentioned in the very beginning, it's a DataStream API. But also I mentioned there's some other APIs. And one of the APIs, surprisingly, would be SQL. When I was starting my software engineering job, people told me that, oh, you need to write like apps, you need to know SQL. And I was like, yeah, why I need to know SQL? We have a Hibernate, right? Like, who needs the SQL? Like, you're just writing your stuff in just save all, and that's it. You don't need to worry about SQL. Anyone has a similar sentiment? No? Nah, yes, we were wrong. I was wrong, and now I'm wrong. And 2025, SQL still going strong since 1992, right? Thing is that SQL is a language for querying the data. And here we are using this for stream processing thing. Now, in the world of data, it is actually query language that allows you to build essentially projection on top of the data that you're storing in your tables. So in the world of data streaming, especially for the last 5-6 years, SQL becomes one of the kind of like selling point for the people who wants to do stream processing, but they don't want to learn Java or, God forbid, Scala. Any Scala developers here? Oh, just one. Okay, next year there would be no Scala developers here. Reason why I'm asking, there used to be a Scala API for Flink now, because just only one developer left and no one was using Scala anyway. Scala API gone in Flink 2.0, so it's only Java API there. So, what I was saying, SQL. So the SQL creates impression that, okay, it has a SQL, so is it Flink database? No, it is not. But it allows to express something that you want to do with the data in the language that people kind of, sort of, can understand. No one understands SQL. Everyone, either people who understood SQL, they already retired, and now everyone has just generated their SQL using ChatGPT. Anyone? Tell me I'm wrong. Okay. Thank you. Yeah, I knew that I'm not wrong. So now you can use SQL, and it's more or less a standard SQL that you can use in Flink to express your job. So, for example, this is graph that will implement this interesting topology. So we have a couple things here. One of the things that I learned, important thing that I learned early in my career, the way how I started reading SQL, I always need to read from first, not select, but from. So I don't know why, but that's the way how it is. So in order to understand where the data come from, I need to first of all understand where this data come from. So essentially, that will, let's get back, even before. So we starting at the end, logical, right? Because SQL results, we're going to be insert inside results. In terms of graph, in terms of this DAG, how this data would be pushed back, it would be at the end. At the very end, we're going to do this repartition and get the result into this topic. Next thing is that we need to pick up what kind of fields we're interested in. In this particular case, we are interested in field color and interested in count. So in this particular case, there's two things happen. One thing is that we are selecting grouping, and we need to execute this count function. And the count function requires us to remember what was done in the first place. Remember, we're sending only one message. We're not applying this like in SQL. We're not applying projection. It actually defines kind of how the message will go through here. Now, when we selecting where, that's basically filtering. That's the part where we do stateless stream processing. Filtering, mapping, any type of transformation doesn't require additional state to store. Count will require. And in the very beginning, now we have this from, and this is the beginning, and we touching this in the very end. kind of sort of logical. This is how they're thinking of the Flink program. And it's like a built-in Flink program. In order 1, 2, 3, 4, 5 lines of SQL, it actually can be 1 line of SQL, you might require maybe 50 or 60 lines of Java code. So in this particular case, you already have when you're executing this SQL, you already have environment set up. This SQL will be taken, it will be compiled down. It even will run optimizer in order to see if this topology can be optimized in order to effectively run in Flink cluster. So SQL is kind of nice, the way how you can like play around with your data and stuff like that. One of the things that people usually asking, okay, so you said it's not database, but still SQL, and you kind of sort of get the results from one point and you're storing the results in another point. Flink doesn't have this yet. Someone in community working on this. Flink doesn't have this concept that allows you to query this state, or how you query, say, materialized view in your database. But in Flink 2.0 or 2.1, there would be API that allows to create like materialized tables that you will be able to query without reprocessing. So in this case, it will even more blurring the kind of like boundaries between like, is it like database or it's not database and things like that. Remember, it's still stream processing system. Now, in terms of APIs, runtime and some of the low-level operations, they both are same for DataStream API and for SQL and the Table API. Sometimes I've seen in internets, I've seen different materials where the people saying that, oh, like the Table API implemented on top of DataStream API, it's not precisely accurate because they both using same foundation, but these APIs were written from scratch. Now, we talk about DataStream SQL. What the hell is Table API? So anyone using this framework called JUG, J-O-O-Q? So it is kind of nice way of dealing with database, right? It's not 100% kind of like object relation mapping, like a Hibernate or JPA, but also kind of allows you to stay very close with to your data. It generates you nice DSL or usually type safe DSL on top of your tables and allows you to iterate with this data. Now, so why we have this in the Flink? Because Flink is not database. I don't know. But this API does exactly like this. You, in the Java, you can use power of SQL without dealing with, say, submitting multi-line strings. You have a type safety of this processing, and you have a power of focusing on the logic rather than writing like tons of Java code. From how the abstraction grows, we have a level of abstraction growing, and the things what flexibility obviously going down. So for example, if we have a ability to do any type of transformation inside DataStream API, we have maybe less flexible on the Flink SQL. However, in order to meet this, there's also API that allows you to write the user-defined functions. So you still can write the things that you're writing in Java, but make them form of user-defined function, and still will be using either Table API or Flink SQL to iterate. Now, a little quick about the state management, and we'll go for a demo. I don't know, for some reason people love this type of diagrams, so that's, people usually take pictures of it. I don't know. That's why I put this here. So as I mentioned, Flink, it is a cluster. It's a system that runs your computation, meaning that there will be multiple components that need to communicate. When we're writing our Java application, we're usually creating jar that has our code, has our dependencies, and after that, we need to interact with the component called job manager that sits on top that will receive in our job. We're submitting this job into cluster, and our job manager will be getting the jar, validate if it's a valid jar, try to see what's assigned, the metadata is there, what's the class, main class to run. And after that, it turned it into this, the thing that will be submitted across this task manager. So task managers are actual heroes here. So task managers will be responsible for running your actual code. So job manager will be only providing UI, providing like REST endpoint to submit the job, but the rest of the stuff will be here. Inside each task manager, you will have a granularity in terms of how this particular task will be scaled, because you can have multiple tasks of the different jobs running on the same cluster. It's kind of like a collocated environment. So you have ability to maybe even restrict a little bit in terms of like how many resources one job will be taking. And another thing with the task manager, code will be executed there, even if we're talking about our sources, our connectors, things that will be iterating over with the external system. So the task manager will be executing this DAG here. And as I said, multiple sources are supported. So you can have Kafka file system, you can have some real-time data comes from the Kafka topic, and you can have some reference data from file system and CSV files, and you can perform enrichment, and after that send this data back to Kafka or submit to some custom thing, not necessarily to Kafka. You can submit this to any like relational database. So that's a nutshell. There is a tools that allow you to, if you're in operator business, you kind of like running these things. Questions need to be submitted in written form at the end. I'm just kidding. Yes? What happens if the job manager goes down? So job manager will be, the task will continue to be executed. So because they will be implemented here, you probably will not be able, without job manager, you will not be able to get the status of this task and could not get the result back. But this will be continue to run your task managers. Exactly once. What do you mean by exactly once? Exactly once processing how? It's already started. It's already running. It's already running inside this. And okay, I didn't want to go this route because the exactly once will require like its own, because many people will have their own notion what they mean by exactly once. There's this very strong definition what exactly once means in this particular case. People usually think, correct me if I'm wrong, if it's your understanding, that exactly once should be when we produce the data, message broker, and after that consume data. So this loop should be exactly once. Who thinks it's like that? Don't be shy. It's okay to be mistaken. Actual exactly once happens between consume, process, and produce. Message broker is not important here. Exactly once processing is when we consuming one message from Kafka topic. We do the processing of this message and submit this result in the Kafka topic. This cycle is exactly once. And in order this to happen, it needs to be support on the framework itself. Flink has this support, and Flink provides the ways how this exactly once can be implemented, even in case of failures. And also, it needs to be supported by sync in source, because we're dealing with external system. It's kind of similar to how transaction management happens. Like I do like long sigh about transaction, because again, for some reason, people love to do distributed transaction, and they always have questions about kind of how you can write data to database and also write data to Kafka in the same transaction. Question: you don't, because it's not correct way to thinking about this. But each sync needs to support to coordinate this through the framework. So Flink internally it implements like two-phase commit between the sync and source. Also, we need to deal with the situation where when the failures might happen and you have an intermediate state, so we need to also coordinate with these distributed snapshots that Flink will be collecting over the. I will talk about this in a few slides because Flink has ability to collect those things. So there's many things can go wrong, and like that's why I was asking like what exactly means for you exactly once. Like what you're trying to achieve. It's like if you're trying to do kind of a read transaction and get some results, you will be able to achieve this. But if using Kafka connectors, because Kafka connectors sync and source, they support participating in exactly once. And also you need to make sure that your job is also configured to support this exactly once thing. Yes? That's a good point. But since it's a laptop from modern generation, it should be more than enough for us to finish this presentation. But thank you. That's always anticlimactic when it goes down and it's like there's some cool demo happening. We talk about this. Hey, so this is where actually interesting thing happens. So the count requires us to store some of the data somewhere, and as a framework that has a stateful stream processing in it, Flink can provide the state, and each individual task managers will be managing because it basically will be like node that execute stuff, and a local state will be stored inside this node, and we can store the remote backup of the state store inside kind of like some external system. In Flink 2.0, they not finally, but I don't know, maybe it was just kind of like evolutional thinking. They provided the way how the compute would be separated from the store. So you not necessarily needs to have local state anymore. You will be able to have this state, they call it disaggregated state. Essentially, you can store results of the state on HDFS or S3. So when the job will go down, job essentially node will be stateless, and when you restart this in other node, it will be able to pick up the state from remote state instead of kind of storing this locally. Why it was done? If you ever try to deploy anything to places like Kubernetes and you try to deal with the storage, local storage versus network attached storage, persistent volume claims, anyone? It's fun, right? You know, every time you're running something stateful on distributed system that runs on top of another distributed system, it's a lot of fun, especially storage situation. So now with the this new API framework now aware about where data would be fetched, so it will be dealing with the interacting with the state slightly different than it used to be. I didn't talk like at all about time, event time, for the sake of saving a little bit more time, no pun intended. But there's very sophisticated, and there's a lot of interesting books can be written about the way how the Flink handles time and how it handles late events and how it handles with the different time frames. Because usually, even if you're processing unbound stream of data, you really don't care about like infinite. You want to know like what's the average for the last 5 minutes within, I don't know, sliding window of 3 minutes or something like that. So Flink provides like fantastic framework for handling the watermarks with watermarks, because it needs to be generic enough, but also support the different type of semantics that might be available on a different system. For example, like Kafka Streams doesn't have a concept of watermarks. Kafka Streams handles the time is differently. It's just like another dimension on top of your key value stream. It has a key table that will represent by key value of the Kafka topic. Plus, you have a time. It would be another dimension. It would be like windowed store. In Flink, there would be special messages injected in your stream. You will not be able to access them programmatically as a developer, but Flink operators and Flink jobs would know that this is particular piece, this is watermark that will be signify boundaries or particular time frame that you will be imposing on top of your stream. So it's actually pretty cool. State and snapshot recovery. So Flink has ability to do things on demand. It's called save points. Like you need to restart your cluster, you can create a save point. Individual node will stop the processing, will get the state, put it down, and you will be able to safely restart your cluster. And after that, when you restart, the save points will be recovered. At time to time, some of the jobs will be asynchronously dumping the state into the file system, and then this would be called checkpoints. If you looking for the fun time and entertain yourself, Google. It's called Lampord's distributed snapshot algorithm. It's actually pretty cool. It explains how different distributed system implement this snapshotting in a situation when there's processing running, but you still need to, get the snapshots because from different individual node. Now you need to figure out how to coordinate those snapshots in order these snapshots will be, it's called like Lamport consistent distributed snapshot or something like that. It's actually pretty cool. But if you would take a picture of this speaking.gamov.io, you will see the resources there. I will put the resource where you can read all about this. Not yet. we haven't seen some of the code. Let me switch to my. Oof. Now you cannot see me. I'm behind my laptop. The simple app. We started with this. We're getting data from a list of objects, from the list of strings, and now I'm performing some sort of computation. In this particular case, if I run this, hopefully it will not break. It didn't. As individual results, because we're outputting this to the console, and there's no way for me to tell you like which message would be written first or second. So that's why Flink says like different nodes will be specifying where this result come from. So, and this particular job will be executed and will collect length of this word. And after that, just for each individual message, it will speeds up this result. As you can see, the results will go per message. So we got the apple, apple, banana, cherry, date. Because we didn't specify the way how this data would be processed, the Flink will decide how it will this individual messages will be balanced across different nodes that will execute this Flink job. Flink works fairly well with modern technology. Flink supports Java 17 and Java 21. Java 17, I guess, right now is the baseline for Java in the Flink 2.0, but Java 21 also supported. As you can see here, I have a record, and Flink works fairly well with records. So hopefully it will not break. The reason why I'm saying this is that when Flink is not very well working with the module system. So every time you will be looking into how to execute the jobs in the Flink, you will see there's a bunch of kind of like open statements. So Flink uses a lot of reflection when performing serialization of Java objects. So that's why like frameworks like Cryo that is used internally inside Flink, those frameworks require to get access through reflection. It can be avoided, but in this case, you need to be very explicit about your types. So in this particular case, like in my processing here, say for example, if I would say simple job, I'm very explicit about types. So the type can be inferred in some cases, but Flink uses reflection to do a lot of things. So I need to be like very explicit about my particular types. Flink, because of the table API, has a concept of row. You can also use this to get the data in. So it's very similar to what we do with tuple. Usually tuple, because the tuple have like tons of implementation of this tuple. Where is it? And whether I want to do tuple, say 25, and it has like, this bullshit. It's fine. Kind of, they're thinking like there's no 26 because probably people are not gonna use tuple more than, but there would be issue on GitHub when saying, hey, we need to use tuple 26. You need to add this class. And let me see.
If you use Scala.
The API was designed by Scala people, so that's why we have this bullshit. So that's where's my yeah. So like fantastic, that's great. So but we can use, where's the row example I just said? You can use row, and in this case, you kind of sort of don't have this problem. You can have more than 26. However, again, you need to know this all is the things with serialization. This row will be working slower in terms of serializing, deserializing versus tuple. Tuple works, the fastest. And for example, if we're doing with like regular Java objects or the where I have a record here, like person record, in this particular case, it will require this to be serialized, and to serialize this, because I explicitly not specifying serializer here, it will be how it's called, kind of like falling back on Cryo. Cryo can do serialization of the things, but it would be slower, much slower than, so for example, if I would use tuples. It is what it is. That's kind of like benefits of strongly typed system, I guess. It could be worse, it could be groovy, right? Now, for like word count scenario, it's a hello world for data processing. Like if you starting with any data system, write the word count. So in this particular case, we're getting some sentences. So obviously we need to get per message, we need to extract the words. So in this case, we're using flat map, as you usually kind of like would in your Java util stream. Flink has a lot of kind of like a legacy API. Even prior, it was nice and cool in Java. Everything was available there for a Java util stream style API. So that's why kind of like they have like their own flat map. Their input stream is there. It's not inherited any kind of like it's not collection. It's not iterable. So it looks very similar and feels, because of the names of the maps and the way how the interfaces are feel, but it is not like one-to-one mapping. Comparing to Kafka Streams, for example, Kafka Streams has more common things with the collections, Java util collections. So the flat map will create another stream inside this. It's called single output stream operator. So remember these nodes. Each individual node would be operator. This is operator. This is operator. This is our node. Now. And this is where I also need to be like very explicit about the types. So downstream operator, that would be executed not necessarily on the same node. It can be executed on another node. So knows about the types of the incoming stream. So that's a lot of actually, there's one good thing about Scala here. Internally, Flink uses a lot of Akka. Not anymore, because Akka changed the license. They use a fork called Peko, I guess. And internally, Flink uses this framework to exchange the messages with the nodes. And yeah, so if I would let's see, if I run this, it should work. So the way how it will do, again, because we're submitting this message, we're submitting this job, and it will be executed per message. So let's see, we have what we have here on the very beginning. The first message we will have is apple, banana, cherry. So we will see that apple would be emitted with count 1, banana with count 1, and cherry count 1. Now, banana, date, elderberry. So we will see that our banana downstream somewhere, where is it? Banana 2 should be, banana 2. So because we have a memory of the banana, we saw this once. Second time, we will just add this count. The way how it's implemented, it is through some function. So some function allows to perform keyed stream, and after that we can apply the function that will be performing some of the values per particular key. And as a result, will have a where's the data here. So elderberry 3 times, elderberry 3 times, banana 3 times, date 3 times. So in this particular case, we get the stream, we'll do something with this data, and we get another stream. So in order to get the queryable information, how to query this information, that's the topic of my tomorrow's presentation in Amsterdam Java user group. That's It's called how to query stream. I will tell you about all things how to query stream. And one last thing that let me show you some cool bits. So, for example, when we are running this, and still running, very good. So Flink comes with dashboard, very nice, very cute dashboard that allows you to see what is going on in your cluster. Have a job manager that will you will have information about what comes from this, like a memory allocation. You will be able to get the same information through UI. Now, this cluster contains 2 task managers, so the jobs will be separated across them. So I will be able to see what is going on here. There's also memory consumptions, all sorts of metrics compiled here. And I do have some job that's running. And the job is basically, can I, let me see if I can cancel it. If I can restart this job. Canceled. So we have a bunch of, let's see, completed, canceled. So cancel one, running job. Let me do this. I can do submit new job, add new. We are in a folder. We're gonna do. So I already have Gradle shadow jar. So my little project will include all dependencies. My shadow jar will be placed here. Let's see, build. I don't see it why it's there. It's an app, cd app. App. To make it sure it's built. Build app build lib. And we see have two files. One is 81 megabytes. That's my job that includes all dependencies. So if I will just say, I'll take this one, app, build libs. I'll take this all, and I'll go here, say, whoop. So grab this one. And I can submit the job. I can configure like a level of parallelism if I need to provide additional environments. So the save point where I can store the state, I can specify location of this one. So for now, it doesn't matter. It also will show me the plan of this job. So if I'll submit this, snap! I didn't. It's a different job. I think I screwed up the build.gradle should use. Build.gradle should use different main class. Yeah, they should use different main class word count job. It's a wrong one because it needs to using the my movie rating job. But you can play around with this yourself. But essentially, I took this job that I run locally and I showed you how it works. Now I deploy this in cluster. It finished because it only has a limited number or like a bounded stream of data. You know, it was the 3 lines of the messages, so that's why it's executed in the form of batch job. But if I will just do, let me try to quickly rebuild this. So instead of this, I will go with movies, not app, movie. Stream processing job, and just run this. Recompiles, build the shadow jar. Meanwhile, I will just go ahead and just it's completed, so I don't need to do anything. So I will submit new job, add new. Okay, we're done. And this is the movie. So now it figure out that's correct. The entry point shows me what this job will do. So in this particular case, this is example. Again, you can play around with this yourself. I will publish this. So we have a data generator that write data into Kafka topic. And from the Kafka topic, I'm reading this data and perform join. So in this case, it will generate me a plan of execution of this job. And after that, I just click submit. And now this task would be constantly running. well, a few seconds, will require this to job to establish connection to Kafka, and data will be reading, and we will start seeing the different data that goes into in and out these pipelines and things like that. So that would be execution. So with this, my name is Viktor Gamov, and as always, have a nice day. I will be available for enhanced interrogation all evening, and like I said, tomorrow, Amsterdam Java user group, we're gonna have a fantastic co-speaker with me tomorrow. Yes, so come to learn a little bit more about Elastic. I'll learn about the Kafka and how to query streams, and thank you.
Great.